In this problem, we are asked to find the critical value for a right-tailed matched pairs t-test. And I have gone through a full hypothesis test in another video. They're linked, hopefully, if not down here at the bottom, you might see a written example where there are some links to different videos you could look at for a few different scenarios. So for this one, I'm going to just focus on showing you how to find the critical value for a right-tailed test. Whenever you have different types of tails for your tests, you have to consider a few nuances. So when you do a two-tailed test, then you have a critical value that's negative on the left, the center is 0, either for t-test or z-test. And in this case, we would be doing a t-test because we're working from sample data. And excuse my handwriting, but I'm using a mouse right now to, to draw. So if you have a two-tailed test, then your alpha is going to be equally split into the two tails. So in the left tail, you would have half of your significance level alpha for a two-tailed test. So in this case, if this had been a two-tailed test where your symbol right here, if your symbol right here had been a not equal to 2 sign, then we would know it was two-tailed. We would take this alpha of 0.002 and we would have divided it by 2, and then we would have had 0.002, and we would have used that when doing the inverse t to find our critical value. But since this one is a right-tailed test, I'm not going to have the two critical values in my alpha then, since I only am going to have one tail on the right and not the left tail, then I'm only going to have a right tail with all of the significance level in that single tail. So it would be the 0.002, and I meant to put 0.001 over here, which would be half. So if it had been two tails, then I would think of each tail as 0.001. But because this one has a greater than symbol in the alternative hypothesis, this is a right-tailed test, and I would not have this left tail at all, and then the full alpha would be just in the right tail. So I'm going to have a positive critical value with an area of 0.002 to the right. So if I put in 0.002, it's going to give me my negative critical value. If I want it to give me the positive critical value, I would have to do 1 minus 0.002. And then the degrees of freedom will always be the number of pairs or the sample size minus 1 and minus 1. So here we had a sample size of 66. So this would be 65 degrees of freedom. If you had a table of values, you would count the number of pairs and then subtract 1 for your degrees of freedom. So by doing this, I'm going to be given the positive critical value. You see, just on that one side. Another way of getting a positive critical value is I could have just done it without the 1 minus, and then it would have given me the negative critical value. But since I realized that this is a right-tailed test, I should know that my critical value should be positive. So, you can just use that knowledge as well as an alternative.